So let's say we have a combination of mirror. So we have two concave mirrors. You can see here. The focal length of each mirror is f1 and f2. The separation between the mirror is just called d.
The call from out.
So d is the separation, f1, f2 are the focal length of two mirrors. Now the question is, if you keep some object between the mirrors somewhere, I don't know where. So question is, for what value of d, the okay, I think like this, the light ray first hits the mirror one. This is given that the light ray hits the, just call mirror one, mirror two. So light ray first hits the mirror one. What does it mean? If the light ray will hit the mirror one first, I mean, this is what we are assuming, then the first image will be formed by mirror one. The question is, the first image formed by the mirror one will act as the object for the mirror two. This is normally happens. So if light is going and hitting the first mirror, then the first image formed by the mirror one will act as the object for the mirror two, and then it will form the first image of itself. So mirror two will form the first image, which will be the image of the image of f1. I mean the mirror one. So this thing this way, the light ray hitting the mirror one, which means the first image will act as object for the mirror two, and now it will form the image of that image because that is acting as the object. And it is found that the image of the f2 or m, you can say image of the m2 coincides with the object itself. Okay. So if image of m2 coincides with object itself, then find d. Let me put this. This is the question. So I hope the question is clear.
Yes.
So the light
Yes.
ray hits the mirror M1 first, then M2, considering just one reflection from each mirror. If image of M2 coincides with object itself, then find D. So when it is possible that the image will come, image will be O only. The image of M2 will be O only. So you have to think about it. It's something which you can solve easily. There are many ways to solve. And of course, don't try to solve mathematically, just common sense will give you the answer. You have to use the concept of ray diagram. I think we have to find the D minimum. We find D minimum. This is from SEO only. You can just open the book of SEO and you can see it. Yeah. So I think so the book. Question number 12. Okay. So if you think of the properties of a ray diagram, you can easily solve this question. So imagine the O point is the focal focus of the mirror M1. So if that is the case, then any light ray traveling from this point O will become parallel, because if the light ray parallel focus converges at focus, then the reverse phenomena, the according to the to the principle of reversibility of light, any light ray which begins from the focus must become parallel to the principal axis, like this. And it must come back to O, which means the O must be the focus of the M2 also. Then only it is possible. And so the distance is how much? You can clearly see. So D turns out to be. The other answer could be if O is the center of curvature of both. Because if O is the center of curvature of both mirror, the image will be there only. So D minimum will be this much. Then what is the D maximum if I ask? The D maximum will be 2f interceptive, because if either O is focus of both, so this is a solution. So either O is focus of both mirrors, or center of curvature of both. So you can solve in these two ways. If they ask the minimum, then we can say f equals f. The ray diagram is self-evident. If it is center of curvature, what will happen? The ray will just retrace the path and will hit the other mirror, and will again just only one image you can see. Okay, so I think you should solve question number 13 also from SC1. This is similar to the question number 12 of SC1, not exactly. So it's a midpoint, so you can do the same thing. So in the question of SC1, what they have given is O is the midpoint and focal length of each mirror is equal. Then of course it should be either 2f or 4f, right? So this is question number 12. So try solving question number 13.
Yes, sir.
Then I'll go to the next concept. Okay, have I missed that?
There is one lecture PDF you are not sent.
Yes, I'm done with it. Always remind just after the lecture, but there are so many PDF that it's difficult to solve. Anyway, and such. So we what we have here is one is a concave mirror, other is a convex mirror, right? And just name it M1. The question is a converging mirror M1, a point source is diverging mirror M2 arranged like this. The source is placed at a distance 30 centimeter from M1. So source is placed at a distance of 30 centimeter. Okay, fine. The focal length of each of the mirror is 20. So focal length is 20 each. Okay. Consider only the image formed by the maximum of two reflections. It is found that one image is formed on the source itself. Find the distance between the two mirrors. Find the location of the image formed by the single reflection from M. So Now image is only one. When it is possible, we have only one image. Tell me, when it is possible? How you solve? Explain. Hello, hello, hello. Am I audible? Harshit and Athar. Am I audible, guys? Hello, hello. Hello, guys. Am I audible? Hello, 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 hello. Yes, am I audible? Unmute yourself and say something. Yes.
Sir, are you saying something? Hello.
Yeah, of course I'm saying something. Am I audible? No. Am I audible now?
Yes, sir.
Yes. So what will be the condition for the single image to be found? What you did?
Sir, I calculated the value 50.
Oh, oh. Like what was the question? Tell me the question. What you wrote? Tell me.
Serious.
Send me the solution. Whatever you have solved, just send. Me.
So the
What?
equations.
Yeah, everything. Whatever you've written, just send. Me.
Yes, sir.
I think separation between the mirror is not given, right? No. You can apply the mirror formula for the F is here. F, you can say F1. So the distance from F1 is just 10. So 10 into xi is 400. So the distance from the focus will be 40, and the total distance from this point will be 60. So this is the distance is 60. So how you solve? Like you're not sending me the image, it means you are just lying to me. Huh?
Should I send you the image?
I
Hello.
haven't received. I haven't received any.
So wait, I will see. Again. Hello.
Yes.
Sir,
Okay.
I sent you.
I'm just checking it. So you assume the D as a separation,
Yes, and X also.
and 1 by F equals to 1 by G minus 30. So what is U taken U is this, and V is what you written, D minus 60.
Yes.
You written D minus 6 something, right? 61. So what was the question? What they asking?
To find the distance, right?
To find the between the
Distance.
distance between the mirror. So you can do it directly. See the light ray, the ray diagram. If I want to draw, it will be like this. The image will be from there only. If it hits the mirror at right angle, then it will retrace the path and we come back. And this means if I extend this line, it must be the center of curvature of the, and this must be 40. So this must be 40 value from there. Then only it is possible. Then the image will coincide with the object itself. It will just retrace the path and will come back there. Okay. So you can see that the image will be this is the virtual image. So the image of the first mirror must be at C. And how much we are getting the image of the first mirror? We are getting 40 from the focus. How it is possible? In this way, it is not coming. Oh, this is 30 already given. So oh, you have to use the UV rule only. Okay, so we can solve this part here. B square plus 10D minus 600. So D is how much coming? Minus 10 plus minus B square 4AC minus 10 plus minus 50, right? By 2. We can take positive. 50 minus 10 is 40. Okay. Anyway, so separation between the mirror is how much? 30 plus 20, which is 50. Okay, fine. Okay, I think the 30 was given. If they would have only asked the if the final image coincides with the object without mentioning the distance, initial distance, and if we have to find the separation, then we could have done like this directly. So keep in mind the ray diagram. We'll do some question of graphical question. We can simply see graphs. So in case of convex mirror, let me draw the convex mirror. or you can say to confirm that whatever. This, so imagine this is a concave mirror. So I'm taking x-axis, this is y-axis, and the x will become the object distance, and the y will become the image distance. And we would like to draw the diagram for the object and image relation. So we know that 1 by u plus 1 by v equals to 1 by f. Now, if I put everything with proper sign, am I audible, guys?
Yes.
So if you put everything with proper sign, what is the relation of v versus c? Just guys, give me 5 minutes. So we are supposed to plot the graph between v versus u. How to plot? So you can write as 1 by v equals to 1 by f minus 1 by u minus f upon u. So v equals to how much? Now let's substitute everything. So for real object, I mean, of course, we will keep the object real only. So for real object, the u will be always on the left side of the origin. So we can say the u we can write as minus of some value. We can write as mod. And f is also going to be always,
Negative.
and therefore the v formula will be minus mod of u minus mod of f upon minus mod of u minus mod of f, like this. This will give you what? V equals, you can see, mod of u mod of f upon mod of f minus mod of. Now if u and mod of f are equal in values, it means if the object is at focus, we know the answer will be infinity. So if I call this is f, I must draw some line called asymptotic line near f, and if you approach from left hand side, the v is bound to be negative, because as long as this number is bigger than f, the answer will be negative, right?
Yes.
So the graph, and as you go towards infinity, the v will become how much? If u tends to infinity, okay, you can write like this: mod of f upon mod of f upon mod of u minus 1. So if you this tends to infinity, the number becomes minus f, right? If that's we know already, these things we know. You can see clearly the answer is minus mod of f. So we need to do one more asymptotic line at minus f like this. This is minus below the origin. So how the graph will look like? Can you guess? So at as you approach f, it will become infinite, of course, real. So as long as you are before the f, the image must be real. V must be negative answer. So V is negative means what? It is forming the left side. So the graph will look like this. This is the V graph. And at f it becomes minus infinity. So it's become asymptotic. At infinity it is going to be parallel to the f line, which means the value will be minus f. The moment you cross the f line, so at f the answer will be what? If you cross on the right side, the answer is still infinite, but on the positive side. And coming to the pole, the image will be here only. So we know that at pole the image will be there only. It will not change. It will just on the right side. So this is the graph between the V versus U, and you can see there are two asymptotic lines. This is the real part, real image. So real image will be negative, and this is the virtual. Many times they will ask you just plot the real image. Okay, plot the real image, and they will also tell you that okay, take U and V positive in the left only. Like the real images, they will take as positive. So graph will just invert. So if you want to plot only the real part of how you can plot, so for real image, you can simply plot like this. So if only one part is required, like if I if I'm not supposed to compare the U and V for real and virtual, then we can take everything positive only, and you may draw the something like this. So in such case, you can draw a line like this. So you can see you will be positive in distance, right? If I'm drawing like this, and you can draw one more line. So both lines will be f in height. I mean, this is f in length. This is also you can say 0 comma f, or you can say this is f comma 0. This one, and the entire graph will only between these points. Not nice. Something asymptotic will be formed like this. Sometimes they ask the graph of like the v by f versus u by f. So v by f and u by f, then this will become 0 comma 1. This will become 1,0. You need to realize that if you divide v by f, the f line will become 1, right? It's like I'm dividing every coordinate by f. That's it. So again, and this is only for the real image. Real. Okay, so I hope this is clear. Similarly, we can plot it for the. You can plot for the. Okay, so now for convex, we can plot similar. So for convex, if you plot for the real object, I'll plot the actual one first. So in case of convex, as long as the object is real, it will be on the left side for sure. And if you are at infinity, the image will be at f, and that to be virtual. We know that the only thing we can expect is virtual. So now, how the graph will look like? So at a pole, it will be at pole only, and at infinity, it will become the height will be 0, f. So you will have simple graph like this, not not difficult at all. So we are done with the graph part. Have we done the motion part, motion analysis in a spherical mirror?
No.
Are you sure? Okay. So let's do the motion analysis. So for any mirror, we have to describe the motion in two ways. One is the longitudinal motion, and there is a transverse motion. For longitudinal motion, or you can say motion parallel to the principal axis, so for longitudinal motion, component of velocity parallel to the principal axis, we use the mirror formula. And you can also use the Newton's formula. Okay, no problem. So if you differentiate, you get du by dt into 1 by u square. So we are differentiating with respect to time because we want velocity. And u and v, remember, u and v represents distance, not the velocity. Because sometimes you may get confused that u, v are like the kinematics. It's a distance. Unfortunate. F is a constant quantity. If you differentiate, it becomes 0. So the first term is called, and also you need to remember that this uv represents the distance from the pole of the mirror. So these are not the ground frame values, just the distance from the pole of the mirror. So du by dt is called velocity of object with respect to mirror. We never say with respect to ground or something. This is the mirror frame velocity, and this you can say velocity of image with respect to mirror. So velocity of image with respect to mirror turns out to be minus v square by u square. Velocity of object with respect to mirror. If you want, you can put in vector form. That's not an issue. And we know we can write m in multiple ways. So this we can write as vi minus vm. Okay. And you can find the m for a given instant, because at every instant m will keep on change. Okay. Now the answer that we have just got is only for the component parallel to the principal axis. So we haven't got the net value. So for transverse component, So for transverse component, what we can do? We can use the magnification relation. So what is the magnification? If m equals to minus v by u, and if you remember, we can also rewrite in terms of u itself. Okay. So once again, multiply by u both sides. So u by v turns out to be u by f minus 1, which is u minus f by f. So v by u becomes f upon. So minus v by u we can write as f upon f minus. So magnification, why we are writing like this? Because we need just one variable. The u is varied, and magnification we write as the height of image from the principal axis upon height of object from the principal axis. You can write like this. So the y we can write as my naught, the yi. So the transverse component of image velocity is d by dt of. So you cannot just write. You cannot take m outside. M is not a constant. M is a variable because as u will change, m will change. So this you can write as y not a dm by dt plus m dy y. So of course you need to know the magnification of that instant, and dy by dt we can say the velocity of image with respect to principal axis, and of course we believe that the principal axis is fixed. So this is with respect to principal axis, and this will become height of object from that instant. Now dm and dt we can actually calculate separate. So let me keep it like this. And let's calculate the dm by dt. So for that we can use this relation. So it will become f upon f minus u whole square into dx dt. You can say as but du by dt is basically velocity of object with respect to mirror, the longitudinal one. So now if you want, you can substitute. Now of course JE will not ask question like this. So in JE, what you can expect is only the longitudinal relation. And that is the velocity of object with respect to principal axis. So that's the two component, and there is just one question in the sheet in the advanced level problem where you need to use this. The rest you can solve just like that. So most of the discussion will be based on the longitudinal motion only, because the particle will be moving along the principal axis itself. So there is no distance from the principal axis, and the moment you make the term zero, okay, if y naught is zero, then the term will become zero. If y not is 0, of course v not with respect to principal axis is also 0, and this entire term will vanish. So the transverse component only comes when at least the object is not on the principal axis. So if you're not on the principal axis, then you will have the transverse component, else you won't have any transverse component. Okay. So of course you cannot remember all this formula. No need to remember. I would say just know how to derive it, and if it comes in the examination, just derive it. We'll do some more interesting problem from the mirror, like tilting of mirror. So imagine we have a situation where we have a mirror. This is the principal axis. So there are two things: either you can tilt the mirror or you can tilt the shift the principal axis. So now the new principal axis is something like this. Because the new position of mirror is something like this. So let's say you have tilted by the value theta, and the object is here. And let's say we are supposed to find the position of image. So after solving this, for the first case, like just assume that the object is here only and the mirror is in the, this is the initial position, and this is the final. And let's say focal length is given f. So they may ask you what will be the coordinate of image if the mirror is rotated like this. Okay, that's the question. So what you can think that if the light ray is traveling this way, after reflection it will travel exactly at the same angle in this direction. The law of reflection, and we know that the principal axis itself is the normal. So if the angle of incidence is theta for this new normal, this will be also theta. So image will be formed somewhere here. That's the only thing. Somewhere means I don't know where. And how to find the image? So once you know the image in the actual axis, so there are some steps you need to follow. This is the P1 or PA1, and this is PA2. So the rules is to solve question based on rotation of mirror. First, find image position with respect to initial orientation of mirror. Now what we do next is something called the effect of rotation of mirror, which we studied in the plane mirror, that if you turn the mirror by theta, the reflected beam will turn by 2 theta, the double angle. So the image position, if I know on the principal axis 1, I will just rotate that by 2 theta to get the answer. Okay. So that's simple. So earlier the light ray moving towards the principal axis will turn like this. Now this light ray will reflect or turn by 2 theta on this side. But the answer remains same. So the distance from the pole to the eye, I2. So I1 will just turn by I2 by just angle 2 theta. So lengthwise, if I call P as O, so PI1 will be same as PI2 in length. And now you can actually express in terms of original coordinate like this by taking the component. So, and the step 2 is then shift the image by rotating to theta, where theta is rotation of mirror. And if you want to find the answer back to the principal axis 1, you can take the projection. So this is the x and this is the y axis, the original coordinates concept. You can take the projection. So this was JE problem actually, and not accurate in terms of theory, but this is how you can solve the JE problem. Like they believe that the rotation will maintain the behavior of ray optics or the UV formula. So if you solve the JE advanced problem, you will come across and then you can attempt, and in case of doubt you can ask. We solve some interesting question like effect of like or just make a heading like cutting of mirrors. So we have two variety of cutting of mirrors. Like you can uh, cut and shift transversely. That's the first case. And cut and shift And we are going to do this by the very small value. So let's say we have a mirror. So now you can see there is a principal axis that you can see clearly. It's here. Okay, and there is some object here. Oh, and what we do is we actually cut and shift transversely. Like the first mirror I shift upward, and second we shift downward. I'm not showing that part. I mean, of course, it's difficult to cut and shift here. So after cutting and shifting, so when you cut and shift, the principal axis will actually shift for each part. This was the PA. Now we have PA1 and PA. So basically, there are two principal axes, and because we have two principal axes, the object will appear differently for each part of the mirror. So the upper mirror will see the object here, and the lower will see the object like this. So if I call this shift as a D naught, this will be how much? D naught by 2. So D naught by 2 will behave as the size of the object, right? Do you realize this? The same object O will behave as two separate objects for each mirror, and each mirror will see the size of the object, or transverse distance of the object will be D naught by 2. So we can write something. So shift of mirror will shift the principal axis. Therefore, the original position of object will be or you can say will shift transversely with respect to new principal axis. Okay, so that's the only concept that happens in this case. So the moment you cut and you shift, what you can understand here is let the focal length remains same. The f will not change for the mirror. So if f was original, then f will be for both. The f remains same, and therefore the image. Let's say this is beyond f. This is, let's say, at a distance more than f. It will form the real image for the real object because it's concave mirror. So we can say the image may be something like this. I mean, slightly magnified. So the first image will be like this, second will be like this. So you will get two images, one here. So this is the object one. This is the object two. You can think like this. Let me remove this O. So original object O will become O1 and O2, and their image will be how much time? M times the size of the object. That's it. So generally, what they ask is the separation between images will be how much? So we are not solving. We are just writing the answer, assuming it's a real. Because once you assume it's a real, you can add the answer, and mathematically everything will be maintained. So that's okay. So, so the separation between the images I1, I2 we can write as how much? And you can see this is the modulus. I'm just writing the value. So what we can write the answer? You can see it's mod of m d naught by 2 plus d naught plus mod of m d naught by 2, correct? This turns out to be 1 plus mod of m into d naught by 2. Understood?
Yes, sir.
Or I think we can remove the mod because if yeah, I can. Next part is when you shift. Now this is bit difficult to understand. So the longitudinal shift. So the question that will be coming here is like when the shift is longitudinal but very small, not much. So basically, you can think this way. Hmm. So longitudinal shift means the principal axis remain the same. You just shift the mirror slightly, and now this gap I'm going to call as d naught. And we are keeping this distance very small. Now, why I'm keeping it very small? Because the distance between the mirror, actual mirror, and the object is essentially same for both, because the d naught is very small. So to solve such question, what we do is we assume one mirror and two objects at a d naught separation. That's how we imagine. So again, you get two images separate, not just one image. Just- So because we have two mirrors and the object distance will vary for each mirror slightly. So you will get two images and the two images will be slightly far apart. And we're supposed to find the separation between the images in this case again. So the way of solving is you consider just one mirror and imagine two objects at a separation d naught. That is a better way of thinking. And what we need to use is the longitudinal magnification formula. So we can directly write ml, which is dv by du, if you remember, which is always minus m square. So the dv, the separation between the images, is the longitudinal square into du. And while calculating the linear magnification, we can consider it to be a single point and single mirror, and ignoring the d naught value because that's anyway very small. So the magnification we can that is f upon f minus u, or you can say the value is f upon distance from the focus. Sorry. Okay. And therefore the image separation dB will act as the and du will behave as the object separation, which is same as the separation between mirrors. So we are considering d naught as very smaller than f. That's why we are doing all this calculation. Okay. We can say the separation between the images will be minus f upon f minus u whole square into d. No, that's not. So these are of course challenging problems. You have to think this way. Now, based on this, we can get a very interesting problem as well. The longitudinal magnification having multiple uses. So imagine we have again a mirror, and so imagine this mirror is oscillating with a very small amplitude, x equals to a sine omega t. This is the origin. Let's call it pole P. So we have an object which is fixed. But because the mirror is oscillating, the object position will also shift with respect to mirror, and so the image position of the object will also shift with respect to mirror, and hence with respect to the ground. The question is, if the mirror is oscillating with A amplitude, what will be the amplitude of oscillation of image? Assuming A to be very small compared to F. So if F is the focal length, so it's called oscillating mirror. Mirror problem. So what we can say is that if A is much less than F, find the amplitude of oscillation of object. So if mirror is oscillating, then what is the amplitude of oscillation of object? That is what you have to calculate. Again, we can think the same way. Imagine the mirror is fixed and the object is oscillating. It's the same thing. In the mirror frame, the object is oscillating. And the amplitude remains same in every frame. The displacement may change, but not the amplitude. Okay. So again, the similar answer will be there. dV equals to minus m square du. So we just need values, so we can just ignore the minus sign. Ignoring sign. So amplitude of image will be, and amplitude of image so the amplitude of a mirror will be same as the amplitude of object, because if you shift the mirror in the mirror frame, the object will shift in a similar fashion. So that's why you can directly write this solution. Okay. So this is the application of the longitudinal magnification in multiple ways. We can have some more interesting questions from here. So there's very interesting question that we can think of. Imagine we have a mirror and uh, let me frame the question called area swept by the image. So imagine you're quite far away from the focus and we have a object of height h naught. Okay. And this object is traveling with a velocity v naught. Mirror is fixed, so the velocity in the ground frame and the mirror frame will be same. So VO becomes VOM also. So question is for for you, between so let's say U is between the it's more than center or radius of curvature. So it's beyond C only. I mean the motion I'm considering beyond C. Or you can write in words. So considering motion of object only between infinity and center of curvature. Find the area swept by image as a function of time. That's very challenging problem. Maybe you can think about it. Okay. So I think the image will be somewhere here, right? And the image will shift towards C. As you move towards C, it will shift towards C. And tip will also go away. So tip path, I mean, I cannot understand exactly how it is. So I can say that the height of the tip, you can say what? Okay. I need to mention the initial position somewhere to begin with. How much I can assume? Okay. Let the initial distance of object to R. In fact, we can, yeah, 2R is fine. Now you can stop. Now we cannot believe that the tip will always move linearly. So we cannot say there is a linear relationship between X and Y, the object distance and so if initial is 2R, then after some time t, the object must have traveled v not t. So what is the distance from the pole of mirror? Can you guess? So distance between this will be how much? 2R minus v not t, correct? Because you started from 2R and after some time t you have traveled this much, we can say 2R v not t. So magnification will be how much? So the height of image upon the height of object equals to minus v by u, or you can say f upon how much you get answer f upon f minus u, we cannot direct, or if you remember the answer at a distance from the focus, and we just need a height value h not f upon h not is constant, f is also constant, but f you can write as minus f, let's say f the value, and u is more than f, so anyway minus f minus, and u is how much? 2R minus minus of minus, so become plus. I mean just mention here. So y height, the height of the object as a function time we got is, oh nice, this I'll get minus because 2R minus v naught t is still bigger than f, right? So we can just take the mod because we just want the positive value. So mod of y r. So in time dt, this will move by travel. This will travel by v naught dt. So the area under the curve will know if at initial this is y, so this is dx. So the area is yi dx, and you just write the yi value. So yi is how much? And dx you can write as v naught dt. And you can start at 0 to t. This is the area under the curve. It's a very complex function. So it turns out to be how much? H naught f, which is constant. And 2r minus f is a constant minus v naught t into v naught dt. So you can take a h naught f v naught constant outside, and we have something dt. This is ln formula, right? ln upper limit upon lower limit is 2r. So area turns out to be h naught f ln. All right, this is the answer. So all the motion analysis is the difficult part for you guys. I mean, like we can introduce kinematics and we'll ask you to solve. So various question of kinematics, projectile motion can be brought into picture. Okay. I mean, I may create a very challenging problem like that's interesting. Hmm. I just got one very good idea. A model, guys.
Yes, sir.
So you can bring the free fall into picture. Let's say if you have a mirror like this, facing upward. Then this is the pencil axis, and the focal length is, let's say, and an object is maybe dropped from this side. This is the object, and we are dropping from a height, let's say h, and capital H. So if this is t equals to 0, then after some time t, this height will change to this is at time t. So h we can write as h minus half gt square. So they may ask you find the image position as a function of time t. Of course, time t will be less than 2h by t. So find image position as a function of time t. You have to find the, you can choose the again light ray is coming downwards. You can choose this as positive x-axis. That is always easy. This is the origin, and then write the values accordingly. Okay. So use the proper sign. So try tell me the answer. I mean, solve this and tell me the answer. Or they may ask you find the relative velocity between the object and the image. Yeah, that's also possible. So now you have sufficient problem to practice from SC Verma. So from question number 73 to 79 is based on just motion. Your homework will be like SCV. So these are your homeworks which you must finish before the next lecture. Now we are in a position to start the refraction concept. I think. But you at least try. Like you will face difficulty in writing the sign properties. So just choose the right coordinate system and just use the coordinate sign that will answer. What is this answer? Okay, look at this the solution. So at any instant the object is here. You can see the position. So you can just add the UV formula if you want. It's easy. Take f as the value. You can put the sign accordingly. So you can u is how much? Minus. Okay, what we need is, sorry, we need a relative velocity. What you're asking? That's a image position. Yeah, that's right. So minus h, and this is which mirror? Convex. So plus f, right? So we got v equals to fs upon f plus h. That's it. You can just write the answer. That's pretty much straightforward. Just writing is the only way you can get the answer. So what I'll do is I'll end the reflection part. I have given the homework from S. Verma. You can solve what you can solve exactly from S. Verma. The first 10 to 12 question, like 30, from 1 to 30. So from 1 to 13 and 73 to 79. Yeah. So these many questions you can finish easily. The next lecture I'm going to start the reflection. So make sure you finish every question before the next lecture.
Yes.
And just tell me the date on which the lecture happened, the PDF part.
Sir, the lecture in which you taught the like tilting of mirrors, plane tilting of plane mirrors.
Okay. I mean, you don't know the date, no? Okay, anyway. Okay, no problem.